Hey, this is Mr. Hanson. We're working on substitution today. This is a way of solving a system of linear equations. So let's take a look at this first problem. It says a man is twice his son's age. The sum of their ages is 51. How old are they? And I wanted to point out to you that we don't need to use variables to do these kind of things, especially in their simpler forms like this equation or this word problem here. Sometimes we can take a look at things numerically. So here's something kind of silly. If the son was 1, the man would be 2, and the sum of their ages is 3. Well, that doesn't make a lot of sense in multiple ways. But let's kind of get to something a little more realistic. We want a sum that's 51. So I'm just going to kind of put that over here. And then we're working with the man's has to be twice the son. So let's say the son's 10, the man's 20, and you get a sum of 30. So we're getting closer. Let's try 15. This would have to be 30. Add them up, you get 45. Now we're getting really close. So if the son were 16, the man would be 32, and the sum of their ages would be 48. And if the son were 17, the man would be 34, and the sum of their ages would be 51. And you could stop right there. Okay. This is a little bit of an equivalent to check and guess. We're just kind of lining up some columns here, thinking about how they're related, and then we're putting in numbers and checking and guessing. And that's definitely one way to do it. But it's not the most efficient way. I think using algebra is probably going to make things easier, especially once you get accustomed to using the algebra. So if we were going to use algebra, we want to define our variables. Let's say x is the son and y is the dad. So two equations here. First of all, one dad equals 2 times the son's age. One dad's age equals 2 times the son's age. And then the second equation, the dad and the son together add up to 51. Okay. Once we have those two equations, the idea is we want to substitute something into one equation so that we're just dealing with one variable, just x or y. Notice how y is alone right here. That's kind of helpful to us. So when we see y in this other equation, instead of putting y in there, we can put what y equals. So we're going to put x plus, instead of y, we put 2x equals 51. And so this is still son's age plus father's age. So x plus 2x, that's 3x equals 51. And if we were to divide by 3, we get x equals 17. So that's the son's age. Now to find the father's age, we just plug in 17 right there. 2 times 17 is 34. That's y, the dad's age. So hopefully you're starting to see how algebra may be better than check and guess. And the more complicated the problem is, the easier it is to do with algebra rather than check and guess. Let's take a look at another situation. A burger and 2 fries cost $7. A burger, let's make that x. Fries, let's make that y. So x plus 2y equals 7. And 2x plus y equals $9.50. So we want to figure out what the cost of one burger and one fry is. And there's a couple ways we can go about this. We can notice x is already kind of, there's no coefficient or number in front of x, there's just a 1 there. Same with the y there. So either of these two are really good possibilities for an easier solution. So let's just get y alone this time. So if we got y alone on that bottom one, we're going to subtract 2x from both sides. And we get y equals negative 2x plus 9.5. Okay. So we started by working with the second equation here. Now we can go up to the first equation. We're going to write x plus 2 equals 7. Notice I put a big blank in right next to the 2 where y would have gone. And in place of that, I'm going to put this. I'm going to put what y is equal to. So I'm going to put negative 2x plus 9.5. Okay, at this point we have to simplify the left side here. So this is going to be, we're doubling that whole thing, that whole quantity in parentheses. So that's negative 4x. And 2 times 9 is 18. 2 times 0.5 is 1, so you get 19 plus 19. And now we have a nice equation there. We can combine some like terms. So negative 3x plus 19 equals 7. Let's subtract 19 from both sides. And this is going to be negative 12 equals negative 3x. Divided by negative 3 on both sides. And x is 4. So we know it costs $4 for a burger. Now if I plugged in 4 right there, I have 4 plus 2 orders of fries equals $7. I'm going to subtract 4 from both sides. And we've got 2 times the cost of an order of fry equals $3 divided by 2. And the cost of a fry is $1.50. So the burger is $4 and the fry is $1.50. Now this is kind of nice information, because once you've solved this, you can think of any combination you want of burgers and fries, just times the number of burgers by 4 and the number of fries by $1.50, and you're going to get your ticket price or your meal price. So that's another example of substitution. I want to give you some steps to substitution. First of all, you get a variable alone. So far, well, in the previous one we had to get y alone, and in the one before that there was one that was already alone. Second, rewrite the other equation using substitution. So you substitute what the variable is worth into the other equation. Third, solve that equation. And then fourth, once you've solved the equation for one variable, put the value in for that variable to either of the first two equations, and you can find the other variable. Okay, I wanted to show you some situations that are going to come up, and I don't want you to look at them and think that they're weird, but I want you to recognize that you can do them. First of all, sometimes you'll have something in function form like this one up here. I'll label it number 1, where y equals 2x plus 6 and y equals 4x. This is actually really nice. It works out nice and easy. All you have to do, y is already alone, all you have to do is substitute that 4x, just plug it in right there, and you have 4x equals 2x plus 6. And from there you subtract the 2x. 2x equals 6, divided by 2x is 3. Once you know x is 3, put it back in there, and y is going to be 12. So 3 comma 12 is your solution. That's actually an easier one when you have them both in function form like that. Okay, let's take a look at this one right here. X plus 2y equals 12, and 3x minus 4y equals 6. Well, we could get the x alone, the y alone, the x alone, or the y alone. I'm choosing this x right here because it has a coefficient of 1 in front of it. So if we got x, if we had to choose one of the others, we'd have to divide by 2 or 3 or 4. And as soon as you start dividing things, you're going to end up with fractions sometimes that are more difficult to work with. So here's kind of a rule of thumb. Whenever you have one x or one y, that's the thing that you want to isolate. So in this case, let's subtract 2y from 12. So we get x equals negative 2y plus 12. Then I'm going to rewrite this one. 3 and blank minus 4y equals negative 6. In the blank here, I'd put negative 2y plus 12. And we end up with negative 6y plus 36 minus 4y equals negative 6. And from here, I'm not going to finish the problem, but you can see that we have avoided having to work with fractions, which was kind of nice. Okay, I wanna do this one up in the right corner with you. So that was number 2. Number 3, it says 3x minus y equals 20. I'm going to get y alone up here. So you subtract x from both sides. So we get y equals 8 minus x. Now when I plug that back into this equation, I've got 3x minus, and in place of y, we're going to put 8 minus x equals 20. Just be aware that when you subtract a quantity, you've got to kind of use the distributive property. This is like an invisible 1 here. So negative 1 times 8, so we've got 3x minus 8, and negative 1 times negative x is positive x equals 20. So when you have a negative there, you kind of have to distribute out that negative sign. It changes the signs of all the numbers in parentheses, all the values in parentheses. And from there you could go ahead and solve for x. Once you had x, you'd bring it back up here and find out what y is. So I just kind of wanted to get you started on those so you're familiar with maybe some things that will pop up. Let's look at one more. This one, 3x plus 5y equals 18, and 7x minus 3y equals negative 2. If I were to divide everything by 7, I get some really difficult fractions, or by 5, or even by 3. But it can be done. I wanted to show you that it can be done. You can work through it with fractions. Later on we'll look at another way to solve this system that might be a little easier. But let's work through this, and I think the rule of thumb is to divide by maybe the smallest number, or get the coefficient, the variable alone that has the smallest coefficient. So I'm gonna get y alone right here. So I'm going to subtract 7x, and I've got negative 3y equals negative 7x minus 2, and divided by negative 3, and I've got y equals 7/3 x plus 2/3. Okay, now let's take a look at the top equation. We've got 3x plus 5 equals 18. I did a big blank for y because we want to substitute this in. So we've got 7/3 x plus 2/3 there. Okay. Now you can tell that we're going to have some fractions, and the thing that you can't do here is you can't change them to decimals. Think about if you changed a divide 3 to a decimal, you're either going to get a 0.33333, on and on and on, or a 0.666666, and that kind of stuff isn't going to be very helpful to our situation. Or if you were to divide by 7, which we aren't doing in this case, then you're going to get a very long decimal that it ends up repeating after a while, but it gets complicated. So we want to keep things as a fraction. Let me go ahead and distribute this out. This is 35, it's 5 times 7, 35/3 x, and 5 times 2, 10/3 equals 18. Okay, from here, if we want to get rid of the fractions, and I kind of like doing that, kind of makes things a little simpler, we can times both sides, so I'm going to put a big parenthesis here, by the same number. And if you multiply by 3, you can kind of imagine what's going to happen with the divide by 3. They'll cancel out. So let's just multiply everything on both sides by 3. So we get 9x, and 3 divided by 3 cancels out. We get plus 35x, and 3 divided by 3 here cancels out, so we get plus 10. Equals 18 times 3 is 54. Let's add these up. We get 44x plus 10 equals 54. And we subtract 10 from both sides. So 44x equals 44. And finally, x equals 1. So it's doable. It's not so bad with fractions. There will be easier ways you'll learn about in the future, but it's definitely doable. Let's take that 1 and plug it in right here. You could have plugged it in here, or here, or even there. I'm just plugging it into the first one. So 3 times 1 is 3, plus 5y equals 18. Subtract 3 from both sides. 5y now equals 15. Divide by 5. And y should be, if x is 1, y should be 3. So 1 here, 3 there, that does equal 18. 1 here, 3 there, that does equal -2. So there you have it, 1, 3. So this one took a little bit more work, but it's still doable. Substitution is a nice way to do things. Just kind of a reminder, the 3 steps: get a variable alone in one equation, rewrite the other equation using substitution, solve for that variable in your rewritten equation, and then once you solve for that variable, substitute the value for that variable back into one of the original equations and solve for the other variable. So those are kind of the 4 steps there. And just a thought here, we can do things numerically, but the more complicated they get, the more easy it is to do them algebraically. Hope this was a little bit of help for you on substitution. Thank you very much. Have a nice day.